Okay, so far we've been learning about surface area of three-dimensional shapes. And today we are actually going to start learning. So this is going to be Introduction to Volumes. We're learning about volumes now. And I think volumes are much easier to calculate than surface area. So what do we mean by volume? So let's picture a rectangular prism like this. And remember, for surface area, we meant adding up all the areas of the two-dimensional shapes that are wrapping around that figure. Now for volume, we want to know how much can we put inside of this shape. Okay, so imagine we have a box, a rectangular prism box. How much things can you put inside that rectangular box? And you can think of volume as, for three-dimensional, volume in three dimensions, it's kind of similar to area in two dimensions. Right? And surface area and in three dimensions is kind of similar to perimeter in two dimensions. Because these are concerned with the outside. Okay, so in two dimensions, where the perimeter means what's the outside length, this length here. For three dimensions, what's the outside area, or what's the area of the shapes that are outside of that figure. Whereas for volume in three dimensions and area in two dimensions, these are concerned with the inside of the figure. How much stuff can we put inside? So in two dimensions, we talked about area. How much space does this shape take? And in three dimensions, we can think of how much stuff can you put inside. Okay, so remember, in two dimensions, you pictured area like this. So imagine it's divided it up into squares like this. And we have 1, 2, 3, 4, 5 squares this way, and 1, 2, 3, 4, 5, 6, 7 squares this way. Then how many squares do we have inside this shape? And you can think of this as, we have 5 here, another 5 here, another 5 here, and we have a total of 7 lines of 5s. So we can just, instead of counting this one by one, we can just simply multiply 5 times 7 and know that that has 35 squares. And we can do something similar in three dimensions. Imagine this rectangular prism divided up into, I need to draw diagonally this time, so it's a little bit harder. But let's divide this up like this. Divide it up like this. So instead of squares inside our solid, we have cubes, because it's in three dimensions now. Sorry, my drawing is not very nice, but you get the picture. Right, we have cubes in here, and we have 1, 2, 3, 4, 5, 6 cubes this way. We have 1, 2, 3, 4, 5 cubes this way. Okay, then in one sheet, so imagine I take out the bottom layer. In one layer, there are going to be 6 times 5. You can think of this in two dimensions. There are going to be 30 cubes in that one layer. And we have, how many layers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 layers. So that means we can just multiply the 30 cubes. There's going to be another 30 cubes on the second layer, another 30 cubes on the third layer, all the way up to the 11th layer. So we just multiply 30 times 11 and get 330. So instead of having to count every single one of the cubes in this shape, we can just simply use multiplication to count all the cubes. Okay, so we have 6 this way, 5 this way, and 11 this way. So we can just simply multiply 6 times 5 times 11 to get all the cubes inside this shape. Right? And notice that the cubes are inside of the shape, so that this tells us how much stuff you can put inside. And also notice something about the units. So let's say that this was 6 centimeters. Each of the cube was 1 centimeter, had a side of 1 centimeter. Okay, and then this was 5 centimeters, and this is 11 centimeters. When you're multiplying, let's do 2 dimensionals first. So let's look at this one sheet here. That's going to be 6 centimeters by 5 centimeters. I'm just looking at this bottom sheet. And if I find the area, 5 times 6, it's going to be 30. And the unit, I also multiply the units together, so I get centimeters squared. Okay, and then when I multiply the 11 centimeters to that to get the volume, for the number part I got 330. And for the letter part, I multiply another centimeter to this. So now we get centimeters cubed. So for volume, the unit is going to be cubed. And for area, the unit is going to be squared. Okay, so keep in mind to also cube the unit as well as the number. Okay, so what we've done here with this rectangular prism is actually the general formula for finding the volume of a rectangular prism. So let me draw a rectangular prism. So if I have a rectangular prism, I have the length here, the width here, and the height here. The volume of this is going to be just simply multiplying length times width to get the bottom rectangle, and then multiply that. So length times width will give us that red rectangle on the bottom, and then multiply that times the height to get it all the way up to the top. And that would be the volume. So volume is just going to be L times W times H for rectangular prism. Notice how much simpler the formula is than the surface area. Remember, for surface area, we had to do 2 times L times W plus 2 times W times H plus 2 times L times H. The formula for volume is much simpler. And the same thing goes for triangular prism. So instead of having a rectangular base, I have a triangular base like this. Right, there's my triangular prism. The same concept applies. So the main concept with prisms is that you get the area of the bottom polygon, and then you just multiply that times the height. Okay, so let's say if we have a base here, and remember for triangles, you need to have the height that is at 90 degrees with the base. That's the height there. Okay, and since we used H here, let's call this L. Okay, we get the area of that bottom shape. So the volume of a triangular prism, sorry, this triangular prism. First, to get the area of this bottom shape. So remember, for triangle, it's just going to be 1/2 times b times h. And then multiply that times the L, or the height of this prism. And that's it for the volume. Right? Again, it's much simpler than the surface areas. For surface area, you had to multiply the base area of the base times 2, and then you had to find the area of each of the rectangles on the side here. Okay, so it gets much simpler, at least for the formulas, for the area, or for the volume. And lastly, let's look at the simplest of them all. Let's look at the cube. Okay, so remember, for a cube, all the sides have the same measurements. And basically, you use the same method as the rectangular prism. For rectangular prism, we multiplied L times W, and then multiply that times the height, right? You can do the same thing here, except all L, W, and H are all the same. So it's just S times S times S. Right? Oops. The volume is going to equal S times S times S. And another way, or a shortened way of writing that, is S cubed. Okay, so this is why when you have an exponent of 3, you say cubed, because this gives you the volume of a cube with this measurement. Also, when we had a square with an S and a S, to get the area, you'll need to do S times S, right? That would be S times S, or S squared. So that's why you call this squared. The name is the same as this shape here, because this exponent basically gives you the square of this number, the area of the square with where the side is this number. And that is the same for volume. We call this cubed when it has an exponent of 3, because it gives you the volume of a cube with this measurement, where the side is S. Okay, so volume for cube, oops, I should write that this is a cube. Volume for a cube is just S cubed. Right? Again, it's much simpler. The surface area for volume wasn't that, or the surface area of the cube wasn't that hard either. I think the surface area was just 6 times S squared. For volume is S cubed. I think this is a little bit more simpler. So whichever number you have here, if you know one of the side here for the cube, then you can just find the volume by simply multiplying that number with itself 3 times. Okay, so multiplying or finding the volume of a prism, you just find the area of the base. The general concept is that you find the area of the base like this, and then multiply that times the height. Same for rectangular and triangular. And for cubes, just multiply S with itself 3 times to get the volume.